I'm just gonna make a quickie video here about the relay control portion of the power supply. So I have an external AC source in right now from my AC source to power the board at the 12 volts, and I have two clip leads simulating the feedback from the power supply, and this guy is going to simulate the power supply feedback. So I have my focus, man. Boy, you really don't want to focus, do you? So I have 1, 2, 3, 4. Come on, man. And he doesn't want to focus today. LEDs 1, 2, 3, 4. It's kind of backwards. I haven't yet brought the wires over to the headers, but we'll do that in a minute here. We'll do that later. So right now, the power supply is simulating 0 volts, and the first one's set to 6 by these pots. So we've got 6, 11, 16, and 24. And I don't know if I want those settings just yet for permanent setting, but I'm just guessing that's where I want to be for the moment for checkout purposes. So the cute thing is we can come over to the simulation and we can turn it up. Here we go. We got the first voltage. So this would simulate going from the normally closed range on the first relay to the normally open position, and that gives us the first tap select. So that would give us 11 AC to 22 AC, and then each one beyond that, see as the voltage increases. So we should be at 16 volts input, and then the final voltage there. So we're at 25. So each one of these comes on in sequence to increase the tap voltage that's sent to the rectifier. In the future, I'm going to do this with Triax, and I verified that HP did it with Triax. I wasn't sure, and I asked a friend, but we weren't sure if Triax would work for such a low voltage, because there's a holding current and a holding voltage that you have to meet in order to pass current. But the voltage drop in a Triax should be fairly low. It's 2 SCRs back to back, so it should be like 1.8 or 2.2 volts, something in that range. So the question is, can you tolerate that drop? And if you have enough headroom voltage, that shouldn't be a problem. So if you had like 14 volts, then that shouldn't be a problem. What we want to do is we want to get away from mechanical contacts, because the solid state ones, they don't arc. So, or in this case, they wouldn't arc like a relay arcs. But the desire is to move away from physical relays, so that we have longer lifespan, and then overrate everything for 100 years so it doesn't fail. But I just want to show the voltage part is working, and it's nice that it's working. and that could fire a track if you wanted to. You'd have to go into an opto diac into the track would work just fine. So this would convert over to opto diac just fine. But we'll be using the voltage across the back EMF suppression diode to the relays, because that's where 12 volts is across that diode. So yeah, this is coming along, and we'll have to make some load adjustments with the V and I pots and see how that goes, but it's coming along.